Dear students, in the last class we discussed quadratic equations, the synopsis, what is a quadratic equation, quadratic expressions, the roots of a quadratic equation, relation between roots and the coefficients of a quadratic equations. All those things we discussed in the last class. Today we will solve problems on this. And let us look at the first question. Question 1. If one root of the quadratic equation ax square plus bx plus c is equal to 0 is 3 minus 4i, then 31a plus b plus c is equal to. Okay. See, if a quadratic equation has a complex root, then its conjugate must also be a root of that quadratic equation. In other words, for any equation, if alpha plus I beta is a root of a quadratic equation, then its conjugate alpha minus I beta is also a root of that quadratic equation. Now the quadratic equation what they have given is ax square plus bx plus c is equal to 0. Okay. So we have 3 minus 4i as one of the roots. If 3 minus 4i is a root, then its conjugate is also a root. What is the conjugate of 3 minus 4i? Conjugate of 3 minus 4i is 3 plus 4i. Okay. So now what we can say? These two, 3 minus 4i and 3 plus 4i, are the roots of this quadratic equation. So we can go for finding a quadratic equation whose roots are this. If alpha and beta are the roots of a quadratic equation, then that quadratic equation is obtained as x square minus alpha plus beta into x plus alpha beta equal to 0. So here x square minus of sum of the roots. If I add these two, 3 minus 4i plus 3 plus 4i, 4i gets cancelled, 3 plus 3 is 6 into x plus 3ab, the product of the roots, 3 minus 4i into 3 plus 4i is equal to 0. So you get x square minus 6x plus, if I multiply this, a plus b, a minus b, a square minus b square, 9 minus 16 square, a square is minus 1, so 9 plus 16 which is 25. X square minus 6x plus 25 equal to 0. So now if I compare these two, this equation and this equation, we observe that a is equal to 1, b is equal to minus 6 and c is equal to 25. I am comparing a equal to 1, b equal to minus 6 and c is equal to 25. What do we want? We are asked to find out 31a plus b plus c. 31a, 31 into 1, that is 31, plus b, b is minus 6, plus c, what is c? 25. That's equal to 31 minus 6 is 25, plus 25 is 50. That, let us verify the options. 0, no, not equal. 2a, what is a? 2 into 1, 2 we get, so that's not the answer. 2b, 2 into minus 6, so that will give you minus 12, so that cannot be the answer. And then 2c, 2 into 25, which is equal to 50, that's the right answer. Fourth option. Okay. Next question. Question 3. If the arithmetic mean of the roots of a quadratic equation is 8 by 5 and the arithmetic mean of the reciprocal is 8 by 7, then the equation is. Okay. So what they have given is the arithmetic mean of the roots of a quadratic equation is 8 by 5. Arithmetic mean. Let me take the two roots as alpha and beta. Okay. I have taken the two roots of this equation as alpha and beta. Then arithmetic mean of these two roots is 8 by 5. Arithmetic mean of a and b is a plus b by 2. So the arithmetic mean of alpha and beta is alpha plus beta by 2. Alpha plus beta by 2. That is equal to how much they have given? 8 by 5. Okay, so from this I can write alpha plus beta is equal to 16 by 5. Let me take this as equation 1. Okay, so now plus beta is equal to 16 by 5. What else there is? The arithmetic mean of their reciprocal. There means the roots. The reciprocal of the roots. Roots we have taken as alpha and beta. So their reciprocals are 1 by alpha and 1 by beta. The arithmetic mean of 1 by alpha and 1 by beta is 8 by 7. Arithmetic mean of 1 by alpha and 1 by beta. That is 1 by alpha plus 1 by beta divided by 2. That's equal to 8 by 7. So if I cross multiply here, we get 1 by alpha plus 1 by beta is equal to 16 by 7. Now I will take LCM here. LCM is alpha beta. Numerator will be beta plus alpha is equal to 16 by 7. Beta plus alpha or alpha plus beta can be written as 16 by 5. So I will substitute here. You get 16 by 5 alpha beta is equal to 16 by 7. 16 gets cancelled. Take alpha beta to this side, bring 7 here. So you get alpha beta is equal to 7 by 5. Alpha beta is equal to 7 by 5. Right? Okay. So that means alpha plus beta is equal to 16 by 5 and alpha beta is equal to 7 by 5. Sum of the roots we know, product of the roots we know. If we know sum and product, then we can write the root as x square minus of alpha plus beta into x plus alpha beta is equal to 0. So now the equation is x square minus alpha plus beta into x. Alpha plus beta is 16 by 5 into x plus alpha beta, which is 7 by 5, is equal to 0. I will multiply this equation by 5. When I multiply by 5, we get 5x square minus 16x plus 7 is equal to 0. 5x square minus 16x plus 7 equal to 0. Second option is the answer. Okay, this is the actual method. But in any of the competitive exams, we should not care about what is the actual method or what is the shortcut. The only thing what matters is whether you get the right answer or not, and how quickly you get the right answer. That is important. So in this case, this is the actual method. But let us see whether we can reach this answer quickly or by through another method. Say alpha and beta are the roots. Okay. Arithmetic mean of those two roots is 8 by 5, which means alpha plus beta by 2 equal to 8 by 5. So we got alpha plus beta equal to 16 by 5. So this means the sum of the roots is 16 by 5. Right? Now verify the options. Sum of the roots is given by, what is the formula? Alpha plus beta is equal to minus b by a. For this quadratic equation, for the first option, sum of the roots is given by minus b by a, that means minus 16 by 5. But we want plus 16 by 5. So this option is eliminated. That cannot be the answer. Look at the second option now. Alpha plus beta is equal to 16 by 5. Sum of the roots, minus b by a, in this case it will give you 16 by 5. So this may be the answer. Don't jump to the conclusion that it is the answer. We can only say that it may be the answer. Look at the third option. Here sum of the roots, we will get minus 16 by 7. That's not correct. Because we want 16 by 5. So this option gets eliminated. And similarly, fourth option will give you sum of the roots as 16 by 7. That also gets eliminated. So there is only one option left. Second option, that's the answer. So actually, just by doing this much only, we can get the answer. Okay. Let's go to the next question. Question number 4. The quadratic equation whose roots are the x and y intercepts of the line passing through 1, 1 and making a triangle of area A with the axis maybe. Okay. So we want a quadratic equation whose roots are the x and y intercepts of the line passing through 1, 1 and making a triangle of area A with the axis. Axis is the plural of axis. So with the quadratic axis. Let me draw one line here. So here is a line. I will take this point as 1, okay? There is a line passing through 1, whose roots are the x and y intercepts of this line. I will say let its x-intercept be A and y-intercept be B. X-intercept is this distance, I am calling that as A, and y-intercept is this distance, I am calling that as B. Let A and B be the x and y-intercepts of the line. Okay. Then let A be the area, capital A, be the area of this triangle. Area of this triangle. Then we have to find out a quadratic equation whose roots are A and B, whose roots are the x-intercept and the y-intercept. Okay. So, do you know what is the equation of a line that is having its intercepts as A and B? X-intercept is A and y-intercept is B. The equation of that line is x by A plus y by B is equal to 1. This is the intercept form of equation of a line. If A is the x-intercept and B is the y-intercept, then the equation of the line is x by A plus y by B equal to 1. Okay. So now I will multiply this equation by AB so that this will become Bx plus Ay is equal to AB. This line passes through 1, 1, they have given. This line passes through 1, 1, so 1, 1 should satisfy this equation. That means B plus A is equal to AB. In other words, A plus B is equal to AB. This tells us that sum of the roots is equal to product of the roots. Okay? Then sum of the roots is equal to product of the roots. You can verify with the options also. Okay, I will explain that afterwards. Now A plus B is equal to AB. We have area. Area. Observe that it is a right angle triangle. Let me name this as OAB. This is a right angle triangle OAB. So its area, which is known as A, is equal to half into base into height. Half into A into B. Okay? That means from this I can write that AB is equal to 2A. AB is equal to 2A. Since AB is equal to A plus B, A plus B is also equal to 2A. We want a quadratic equation whose roots are A and B. Sum of the roots we got it as 2A and product of the roots also 2A. So the equation is x square minus sum of the roots 2A into x plus the product of the roots which is 2A is equal to 0. This is the quadratic equation. X square minus 2ax plus 2a is equal to 0 is the answer. Okay. Now, actually, by knowing this, you know sum of the roots must be equal to product of the roots. A plus b is equal to a. Now verify here. For the first equation, sum of the roots minus a by a means you get minus a. Product of the roots we get c by a which is 2a. Sum of the roots is minus a and product of the roots is 2a. They are not equal, so this is not the answer. And here sum of the roots minus b by a which means 2a. Sum of the roots is equal to 2a. Alpha plus beta, or in this case a plus b. Sum of the roots is 2a and product of the roots is also 2a. They are equal, so maybe the answer. And here sum of the roots is a and product of the roots is 2a, so this cannot be the answer. Here sum of the roots is 2a and product of the roots is minus 2a, so again this cannot be the answer. First option, third option and fourth options are eliminated, therefore second option is the correct answer. Okay, in that way you can solve the problem. Next, if 3 plus I is a root of the equation x square plus ax plus b is equal to 0, then A is x square plus ax plus b is equal to 0. 3 plus I is a root of this equation. Then what is A in the answer? Okay. So if a complex number is a root of a quadratic equation, then immediately we can say that its conjugate is also a root. So if 3 plus I is a root, then 3 minus I is also a root. Okay? I will go for sum of the roots. Add these two. Sum of the roots is equal to 6. Then what about product of the roots? Okay? Actually not necessary. We want, what do we want? We want a, right? We want a. Sum of the roots, alpha plus beta, that's equal to minus b by a. So minus b by a means minus a. Here if I add them, I am getting 6. So minus a equal to 6, which means a is equal to minus 6. In this case, we are not asked to find the value of b. If you want b also, then go for product of the roots, so multiply them. 9 plus 1, 10 you get, which the value of b is 10. Then, if p and q are the roots of x square plus px plus q is equal to 0, then p is equal to 1, p equal to 1 or 0, p equal to minus 2, p equal to minus 2 or 0. P and q, x square plus px plus q is equal to 0. Q. P and q are the roots of this equation. P and q are the roots of this equation. Okay. I will go for sum of the roots. Sum of the roots is equal to minus b by a, then give you minus 2. That means 2b plus q is equal to 0. Then product of the roots of p into q is equal to q. Q you bring it this side. PQ minus q is equal to 0. Take q as common. Q into p minus 1 is equal to 0. This will imply either q equal to 0 or p minus 1 equal to 0, which means p is equal to 1. So either q is equal to 0 or p equal to 1. We want what is the value of p, not q. So p may be equal to 1. If p is not equal to 1, then q must be equal to 0. If q is equal to 0, then what happens? Then we get 2p equal to 0. That will imply p is equal to 0. So the answer is either p is equal to 1 or p is equal to 0. P equal to 1 or p equal to 0. Second option is the right answer. Then look at question number 10. If 1 root of x square plus px plus 12 equal to 0 is 4, while the equation x square plus px plus q equal to 0 has equal roots, then q is equal to. So first equation what I have given is x square plus px plus 12 equal to 0. 4 is one of the roots. One root of this equation is 4 they have given. So 4 should satisfy this equation, right? If I say that 4 is a root of this equation, then 4 must satisfy this equation. So substitute. Put x is equal to 4 in this. We get 16 plus 4p plus 12 is equal to 0. So 4p is equal to minus 28, p is equal to minus 7. P equal to minus 7. That p I will substitute it in the second equation. That will give you x square minus 7x plus q is equal to 0. Okay? Given that 4 is a root of the first equation, by substituting there we got the value of p as minus 7. That p I am using here, so we get the equation as x square minus 7x plus q equal to 0. Okay, so now this equation has equal roots. It has equal roots, means the roots are real and equal. When the roots are real and equal, what should be the value of discriminant? Delta is equal to 0. Where delta is equal to 0, I can write that b square is equal to 4ac. Now look at this. B square, we get 49, is equal to 4ac. 4 into 1 into q. So 49 is equal to 4q. Therefore, q is equal to 49 by 4. Q equal to 49 by 4, which is the fourth option. Okay. After that, let us look at question number 12. 12. If alpha and beta are the roots of the equation 2x square plus 6x plus b is equal to 0, where b is less than 0, it is negative, then alpha by beta plus beta by alpha is less than 4. Okay? So alpha and beta are the roots of this equation. The equation is 2x square plus 6x plus b is equal to 0. Alpha and beta are the roots of this equation. I will go for sum of the roots. Sum of the roots alpha plus beta is equal to minus a by a, that is minus 6 by 2, we get minus 3. Sum of the roots is equal to minus 3. And product of the roots alpha beta is b by 2. Okay, then we want to know where this is less than what? Alpha by beta plus beta by alpha. Okay, I'll simplify this. Take LCM. Alpha beta is LCM. Numerator will be alpha square plus beta square. Alpha square plus beta square I write as alpha plus beta whole square minus 2 alpha beta divided by alpha beta. That's equal to right here. Alpha plus beta I'll write substitute minus 3. Minus 3 whole square is 9. Minus 2 into alpha beta. Alpha beta is b by 2. So 2 into b by 2 that will give you b divided by alpha beta which is b by 2. This 2 will come up. So you get 18 minus 2b divided by b. Okay, that's equal to. I can write this as 18 by b minus 18 by b minus 2. Okay, this expression we got it as 18 by b minus 2. Okay, now look here. B is less than 0. Okay. When b is less than 0, what about 1 by b? When b is negative, its reciprocal is also negative. 1 by b is also negative. That means 18 by b is also less than 0. Okay. Because I am multiplying this inequality by 18. On RHS, do 18 into 0, that is 0. 18 by b is less than 0. Now I will subtract 2 from this inequality. 18 by b minus 2 is less than minus 2. 18 by b minus 2 is less than minus 2. So 18 by b minus 2, which is nothing but alpha by beta plus beta by alpha, which is less than minus 2. So alpha by beta plus beta by alpha is less than minus 2. I repeat again. See here. Okay, this after all the simplification we got the answer as 18 by b minus 2. Okay. Here they have given that b is negative. When b is negative, 1 by b is also negative and therefore 18 by b is also negative. If any negative real number is there, if I take its reciprocal, that will also be negative only. After this I am multiplying this inequality by 18. Here 18 into 1 by b will give you 18 by b. Here this will become 0. Subtracting 2 from this inequality, we get 18 by b minus 2 is less than minus 2. And this I can replace it by alpha by beta plus beta by alpha. So alpha by beta plus beta by alpha is less than minus 2. That's what we want. Second option. Okay, let's look at this. If A, B, C are positive real numbers, then the number of real roots of this equation ax square plus b mod x plus c is equal to 0. A, B and C are positive real numbers. Okay, so we have ax square plus b into mod x plus c is equal to 0. X square, I can write x square as mod x whole square. X square can be written as mod x whole square. Mod x whole square is also x square because mod x is either plus x or minus x. When I square it will be x square. Okay. Now, the question is number of real roots of this equation. How many real roots does it have? That's the question. Okay. See here, A is positive, B is positive, C is positive. And mod x is always positive. Whatever may be the value of x, modulus of x is always positive. This is positive, this is positive, this is positive. Then their sum can never be equal to 0. Sum is equal to 0 only when the A, B, C all must be equal to 0. That is not possible because A, B, C are positive real numbers. So this will not have any real root. Okay. For example, you take any value for x, whether you take any real value for x, any positive number or any negative value you take, you will see that mod x will be positive only, irrespective of whether x is positive or negative. Mod x value will be positive only. So sum of three positive terms, sum of three positive real numbers cannot be equal to 0, Hence, the number of real roots for this quadratic equation is 0. It does not have any real root. Okay? You can try with some example. If I take x is equal to 1, then I am getting a plus b plus c is equal to 0. It is not possible because all three are positive. Then their sum cannot be equal to 0, right? Not possible. If I take x as minus 1, then what do I get? Still I am getting a plus b plus c as 0. Not possible. You take x as minus 2. If I take x as minus 2 whole square, what of minus 2 is 2, 2 square is 4, we get 4a plus 2b plus c. A, B, C are positive, so 4a, 2b will be even bigger now. So that sum can never be equal to 0. Okay? So it does not have any real root. Then, product of real roots of the equation t square x square plus mod x plus 9 is equal to 0. Product of real roots of this equation. Okay. So t square x square plus mod x plus 9 equal to 0. Product of real roots. Usually what you do is, your product of the roots, if they ask you, you will go for c by x, or you will write 9 by t square for top t square. No, because they are not just asked what is the product of the roots. The question is product of real roots they are asking. So they are only interested about the real roots of this quadratic equation. We have to see what kind of roots it has. And when you see it does not exist as one of the options, you must be very cautious. Okay? And I am not saying that when this exists always does not exist is the answer. But you have to be careful, cross check why that is present, does it exist or not, that you have to ensure. Okay. So now t square x square plus mod x plus 9 equals 0. Very similar to the previous problem. I write x square as mod x whole square plus mod x plus 9 is equal to 0. Okay. Now look at the coefficients of mod x. Here t square, coefficient of this variable. Here t square, which is positive. T square is always positive. Here 1. T square is positive, 1 is positive, 9 is positive. All the coefficients are positive. You just go back to the previous problem. See, where is that previous problem? Okay, here. Now, just go back to that previous problem. Here A, B, C, they had given it as positive. So I wrote A into mod x whole square plus B into mod x plus C is equal to 0. I explained you that since A, B, C are positive, the sum will always be positive only. And mod x is always positive, so this sum is always positive, so this can never be equal to 0, hence this does not have any real root. Coming back to this. Okay. So now here you observe t square 1 and 9 all are positive, their sum can never be equal to 0. This sum t square plus 10, whatever is the value of mod x you take, whatever the value of x you take, these three will always be positive, right? These three terms is always positive, so their sum cannot be equal to 0. So this does not have any real root. If it does not have any real root, then how can I find the product of real roots? Okay, which is not possible. So does not exist is the answer. Don't write 9 by t square. Does not exist is the answer. If the question is product of roots of the equation, then the answer is 9 by t square. But such a simple question they don't ask. Okay, so product of real roots they have asked. This equation does not have any real root, hence does not exist is the answer. Okay, then if 1 minus p is a root of the quadratic equation x square plus px plus 1 minus p is equal to 0, then the roots are x square plus px plus 1 minus p is equal to 0. This is a quadratic equation. Given that this 1 minus p is a root of this equation, if 1 minus p is a root of this equation, then this 1 minus p should satisfy this equation. Substitute in place of x, I substitute 1 minus p. So you get 1 minus p whole square plus p into 1 minus p plus 1 minus p is equal to 0. I take 1 minus p as a common factor here from these three terms. If I take 1 minus p as common, then what will remain here in the first term? There is 1 minus p whole square. I am taking 1 minus p as common, so 1 minus p will remain. In the second term, p will remain, and here 1 minus p I have taken out, so 1 will remain. Okay, that's equal to 0. Right. Then what happens here? P gets cancelled. Okay. P gets cancelled. You will get 2 into 1 minus p is equal to 0. This implies that p is equal to 1. P is equal to 1. But P1 is present in first option as well as fourth option. Second and third options are eliminated. 1 is present in first option as well as fourth option. So now what we can do, we can go for trial and error. See here the other value is 0, there the other value is minus 1. First we can verify by taking any one of them. I take P as 0. Okay. So if I put P as 0, then you get x square plus, here what happens, I am putting P as 0, right? So x square plus 1 is equal to 0. Okay, so x square plus 1 equal to 0. X square plus 1 equal to 0. Then what are the roots of this? X square is 0 minus 1. So x is equal to plus or minus I are the roots of this. Then 1 minus p as 0 I have taken. So 1 minus 0 cannot be the root. Okay, this is not possible. Then that if I take minus 1, p as minus 1 if I take, then I am going to get x square minus x plus 2 is equal to 0. X square minus x plus 2 equal to 0. So now if you verify, if you factorize it, x square minus x plus 2 equal to 0. P we have taken it as minus 1. Then 1 minus p, that means 2. 2, is it a root of this equation? No. None of them is correct. Just to verify. Say 1 minus p is a root of this quadratic equation they have given. Okay. Sorry. I'm right. They have not asked us to find out what is the value of p. The question is to find the roots of this equation. We got p is equal to 1, right? P is equal to 1, then you substitute here, that will give you x square plus x plus 0 is equal to 0. That means x square plus x equal to 0. Take x as common, x into x plus 1 is equal to 0, which implies that either x equal to 0 or x equal to minus 1. Okay? So x equal to 0 or x equal to minus 1, so third option is the correct answer. Initially I thought that we are asked to find out p, but the actual question is to find the roots of this equation. We got the value of p as 1. After substituting here, we got the equation as x square plus x equal to 0. On solving, we got x equal to 0 or x equal to minus 1. Hence, third option is the right answer. Okay. Then, let's go to the next question. Question 7. If the expression x square minus 5m minus 2 into x plus 4m square plus 10m plus 25 can be expressed as a perfect square, then m is equal to. Can be expressed as a perfect square. What is a perfect square? Say, suppose in a quadratic equation, if I have, say, something like this, x plus 2 whole square or x minus 1 whole square, 2x plus 3 whole square, etc. These are perfect squares. Okay, so when you have perfect squares, then what kind of roots it will have? So if I say x plus 2 whole square is equal to 0, then the roots of this equation are minus 2 and minus 2. That means the roots are real and equal. Or in this case, if I say this is equal to 0, then the roots are 1 and 1. If this is equal to 0, then the roots are minus 3 by 2 and minus 3 by 2. So when that expression is a perfect square, the roots are real and equal. When the roots are real and equal, then what is the value of delta? What is the condition? If the roots are real and equal, delta must be equal to 0. If delta is equal to 0 means b square is equal to 4ac. B square minus 4ac equals 0. So b square is equal to 4ac. So from that equation, what is b square? Minus 5m minus 2 whole square, that will give you 5m minus 2 minus 5 minus 2 whole square is 5 minus 2 whole square itself. That's equal to 4 into A into C. A is 1. C is 4m square plus 10m plus 25. Okay. So let us expand this. We get 25m square plus 4 minus 20m is equal to 16m square plus 40m plus 100. Bring all of them to LHS. 25m square minus 16m square, that will give you 9m square, minus 20m minus 40m is minus 60m, minus 96 is equal to 0, 4 minus 100. I'll divide this equation by 3, that will give you 3m square minus 20m minus 32 equal to 0. So this is a quadratic equation we have got. We have to solve this quadratic equation. We can factorize this. When we multiply, we should get minus 32 into 3, minus 96 m square. When we add, we should get minus 20. So I can go for 24 and 4. So 3m square minus 24m plus 4m minus 32 is equal to 0. 3m into m minus 8 plus 4 into m minus 8 equal to 0. So on factorization you get m minus 8 into 3m plus 4 equal to 0. Either this is 0 or this is 0, which means either m equal to 8 or m is equal to minus 4 by 3. M is equal to 8 or m is equal to minus 4 by 3. Just check whether this option is available or not. Yes, it is available here. Fourth option, minus 4 by 3 or 8. Okay, then the number of real roots of the equation x minus 1 whole square plus y minus 1 whole square, plus x minus 2 whole square plus x minus 3 whole square. Number of real roots, they have asked, x minus 1 whole square plus x minus 2 whole square plus x minus 3 whole square equal to 0. Now look here, x minus 1 whole square, this is a perfect square. So this is a perfect square means, can I say this is always greater than or equal to 0? X minus 1 whole square, being a whole square, this is always positive, greater than or equal to 0. When x is equal to 1, it will be 0. In all other cases, it will be greater than 0. And similarly, x minus 2 whole square is greater than or equal to 0. And x minus 3 whole square is also greater than or equal to 0. So, all three are greater than or equal to 0, then that sum must be always greater than 0. Now you might ask me, sir, why they are not equal to 0? Say, this can be 0, this can be 0, this can be 0. But their sum can never be equal to 0. Because this will be 0 at x equal to 1. When x equal to 1, at x equal to 1, this is 0, but then these two will be positive. Similarly, at x equal to 2, this term will be 0, but these two will be positive. At x equal to 3, this term is 0, but these two are positive. So, at no point of time, we will get all three simultaneously equal to 0. That is not possible. Hence, this equation does not have any real root. Because whatever the real value that I substitute for x in this equation, you will see that that sum is always positive. It can never be equal to 0. So, it does not have any real root. Its number of real roots is 0. Okay. Then, let us look at question number 21. If one root of the equation ax square plus bx plus c is equal to 0, ax square plus bx plus c is equal to 0, is double the other, then the relation between a, b and c. One root is double the other. If one root is double the other, then I will take alpha and 2 alpha. Okay? One of the roots I will take it as alpha, the other root which is double the other given, so I will take it as 2 alpha. Okay? Now I go for sum of the roots, alpha plus beta. In this case, alpha plus 2 alpha. That's equal to minus b by a. So 3 alpha is equal to minus b by a. Alpha is equal to minus b by 3a. Then product of the roots, alpha into 2 alpha, that will give you 2 alpha square, that's equal to C by A. So alpha square is equal to C by 2A. In place of alpha, I am substituting minus B by 3A. Here, in place of alpha, I am substituting this. Alpha square will become B square by 9A square is equal to C by 2A. One of those A gets cancelled. This 9A you take it to RHS and bring that 2 to LHS. We get 2B square is equal to 9AC. So here A I have cancelled, 2 I have brought to this side, so it has become 2B square. Here 9A is remaining, I have taken it to here, 9AC. 2B square equal to 9AC. Okay, students, with this I will stop today's class. We will continue in our next class. Further, if you have any doubts, you can always post in our WhatsApp groups. Thank you.